So I'm trying this with my face in the corner of the screen on top of the editor window. You can tell me if you like this or if you don't like it. I'm trying it out. We'll see how it goes. Um, so before we get around to talking about some of the special type classes that are in Haskell Standard Library, we need to do a short digression on something called kinds. So we saw that in Haskell, every value has, or we could say is classified by a type, right? So every value has some type, and it turns out that also every type is has or is classified by a kind. And so I'm going to explain what those are and why we need them. So to see why, so there's some types that we know of, like, int, char, bool. These are all sort of standard types that it turns out they all have a kind called star. So these are standard types that all have kind. We write it as an asterisk, so kind star. And in particular, they have values, right? They have values, for example, like 3 has type int, x has type char, false has type bool, and so on. Okay. What about maybe? So what is maybe? It is definitely a type, but it's a little different than int, char, and bool, right? So there is nothing of type maybe. So there is nothing of type maybe just by itself. So I can't say, there's nothing I could put in the underscore there, in the hole there, that would have type maybe. Because the reason is, maybe you have to apply it to another type. So for example, we could say, just 3 has type maybe int, and nothing has type maybe bool, right? So maybe int and maybe bool make sense, but maybe by itself, although it is a thing, it doesn't make sense as something that that could be the type of a value. But also, like, so maybe doesn't make sense by itself. What about like maybe either? That doesn't really make sense either. It doesn't make sense too. It also does not make sense. And why is that? And how can we tell what things make sense and what don't? So this doesn't make sense either. And it turns out kinds are exactly what we want to classify these different sorts of things, these different types, and to say what makes sense and what doesn't. Just in the way that types help us say what values make sense and what don't. Okay. So let's see what the type of. So if I can say, I can ask for the type of something, but I can also ask for the kind of something by saying :kind. So if I say, what is the kind of char, it tells me that char has the kind star. And we write : to say when some type has some kind, just like we'd write it for when a value has a type. So let's ask it what the kind of maybe is, and let's see what it says. Okay, so it actually says that maybe has the kind star arrow star. And hopefully this makes sense to you based on our discussion over here. So maybe is not a thing like char that can have values. It's actually, think of it like a function on types, right? This says it accepts a type as an argument and then gives a type as output, or a concrete type. So we could give it int, because int we saw has kind star, right? And then maybe int, that whole thing will have kind star. So we could ask it actually, say, what is the kind of maybe? Well, let's say char. I just did char up there. So if I say, what's the kind of maybe char? Right? Char has kind star. This says if you put in a star thing into maybe, you get out a thing of kind star. So that makes sense that maybe char has kind star. And that means there can actually be values of type maybe char. So we saw some before. Similarly, we could say, what's the kind of maybe int? That also has kind star. But if I ask for the kind of maybe either, I'm going to get a kind error, right? So it says you expected something that has a certain kind, but we got something else instead. Okay. So that's exactly saying that doesn't make sense. And what is the kind of either? So either, right, has kind star, arrow star, arrow star. So because either has to be applied to two types in order to give you something that is a concrete type. So, I could say either, what's the kind of either bool int, right? That is a thing I can say, left true has type either bool int. Sure, that works. Right? Either bool int is a thing of kind star that I can have values of that type. So what else can we do? We can talk about, what is the kind of, so I can do just empty square brackets to talk about the list type constructor, because, let's see, usually we use special syntax for this, so I can say, 1, 2, 3 has type list of int, but actually I could also write that as the list type applied to int. It turns out this brackets int is just an abbreviation for this, and so I can ask what the kind, I can ask what is the kind of brackets, and it's star arrow star, just like maybe, right? It's expecting one type as an argument. I can also ask what is the type of arrow, which is also, it's the same as either, right? Because arrow, again, we usually write it infix like this, but that's just an abbreviation for this. So if I say, lambda x, so let's say lambda underscore x. This is the function that takes any int and ignores it, and then returns the char x, and we can say it has this type, and it's, yes, it says that is fine. So in general, star is a kind. It's the kind it classifies types which can have values. Okay, and then if k1 and k2 are kinds, then k1 arrow k2 is also a kind. And the arrows associate to the right, just like they do with types. Arrows associate to the right. So for example, either really has kind star arrow parentheses star arrow star, which we can write without, we don't need the parentheses when we write that. I don't know, I think I can show you one of the most, there can be more complex kinds, right? So control state. This is one of the most complex kinds that I know of. It's in the standard library in Haskell. So if I ask for the kind of something called state t, it is that. So it says, well, you have to give it state t, you have to give it some type of kind star, and then a thing of kind star arrow star. So that could be, for example, maybe would have that kind, and then another type of kind star, and then that whole thing will be a type of kind star. We'll see what state t is in a few weeks, but you can look it up if you want. You may not quite understand what it is at this point, but you will in a few weeks. So that's kinds, and we're going to use that. We're going to make some type classes. So far, the type classes that we've made have been about types that have kind star, but it turns out we can make type classes for types that have other kinds, and that's going to be an interesting and useful thing to do.